For example, say you run a canoe rental business. You currently charge $12 per canoe rental and average 36 rentals each day. An industry journal says that for every 50-cent increase in price, you can expect to lose 2 rentals a day, and vice versa. Use this information to find the maximum daily revenue. What price should you charge to maximize revenue? How many canoes would you rent at that price? For this example, we could use the information given to find a linear demand equation and then solve the problem similarly to the last problem we did. I am going to approach this problem slightly differently. We know that revenue is price times quantity. So we're going to think about what's happening with the price and the quantity and explore what that means for the revenue. The problem says we currently charge $12 per canoe and we average 36 canoe rentals a day. If we wanted to find revenue, we would multiply 12 times 36. The problem says that for every 50 cents increase in price, you can expect to lose 2 rentals a day. So if our price is 12 plus 50 cents, we can expect our quantity to be 36 minus 2. And our revenue would be 12 plus 50 cents times 36 minus 2. But the problem does not say that this happens only once. It says every time I increase the price. So if I were to increase the price instead by 50 cents x times, my new price would be 12 plus 50 cents times x, and my new quantity would be 36 minus 2 times x. To find the revenue, I would multiply price times quantity and get 12 plus 50 cents times x times 36 minus 2x. So we have an equation for revenue. 12 plus 0.50x times 36 minus 2x. This equation is written in terms of only one variable, so it fulfills the requirements for step 1. Step 2, we are supposed to find the derivative. You can multiply everything out and then take the derivative, or you can use the product rule. I choose the product rule. We multiply the first 12 plus 0.50x times the derivative of the second, negative 2, plus the second, 36 minus 2x, times the derivative of the first, 0.50. We can simplify to get negative 24 minus x plus 18 minus x. So our derivative, r prime, is equal to negative 6 minus 2x. Step 3 is to find the critical points. So we want to know where negative 6 minus 2x is equal to 0. We solve negative 2x is equal to 6. Divide by negative 2. And we get x is equal to negative 3. X is equal to negative 3 is our critical point. For step 4, we need to check and make sure that we have a maximum. We only have one critical point, so we can check using the first derivative test. Remember to label your number line as r prime. We are plugging into the equation negative 6 minus 2x. If we choose a number less than negative 3, say we choose negative 5, plug in, we will get a positive value. Choose a number bigger than negative 3, say 0, and plug in, we will get a negative number. My derivative changes from positive to negative, so my revenue was changing from increasing to decreasing, and I do indeed have a maximum. Step 5, remember, is to go back and answer all of the original questions. The first question was to find the maximum daily revenue. So we will evaluate R at -3. And we have 12 plus 0.5 times -3 times 36 minus 2 times -3. You can use your calculator to evaluate and get $441. Our next question says, what price should you charge to maximize revenue, and how many canoes would you rent at that price? Notice that for price, we have an equation, and also for quantity, we have an equation. So we can calculate our price should be equal to 12 plus 0.5 times -3, or P is equal to $10.50 per canoe. And our quantity Q will be equal to 36 minus 2 times -3, or Q is equal to 42 canoes. So we have our price that we should charge. We have our quantity of canoes that we will rent. And we have our maximum daily revenue.